Hello everybody, welcome to your lesson on 4.8 complex numbers. So in your notebook, please get the title down, 4.8 complex numbers. I know it does say chapter 4. This is a section that I didn't cover in chapter 4, but we're going to cover it as an introduction into chapter 5. So you do not have to write the goals down, but after you get your title, our goals today, our learning targets, are going to be identifying and simplifying complex numbers, and then add or subtract complex numbers. I briefly mentioned this in class, but complex numbers basically is another way of saying imaginary numbers, and we're going to talk about that as we go through this. So the only thing I want you to write down so far is just the title. So some equations have no real solutions. They might have something called an imaginary solution, and that's when the square roots of negatives come in. To overcome this deficiency, mathematicians created an expanded system, and these numbers that end up to be imaginary, they made a symbol for it, and since imaginary starts with I, they made up the symbol I. Be careful when you write the I. If you do this, might be mistaken for a 1. So every time I write my I on my paper, I kind of do a little hook on the end here on the bottom and make it look like that. So I, by definition, this is the next thing you have to get down in your notes, is the square root of negative 1. So mathematicians, when they're doing square root problems, they found that if they put this they got this situation and they kind of put this placeholder in there, sometimes they were able to finish problems because these square roots of negatives ended up canceling. We'll explain that in a moment. But since I is the square root of negative 1, I am now going to define to you by I squared. Before I do that, I'm just going to kind of refresh your memory. If I had the square root of 2 times the square root of 2, the answer to that is 2. Now remember that. There's many reasons why. Reason number 1, the square root of 2 times the square root of 2 is the square root of 4. And I know the square root of 4 is 2, but if you really wanted to overlap all this, you could break it down. 2 times 2, you have a partner, it comes outside, there's nothing left, it's just 2. Now, as we get to imaginary numbers, the square root of negative 1 is I, so I squared is 2i's. I times I. That's another way of saying a square. And since you have 2i's, and by definition, I is the square root of negative 1, if you multiply that by another I, another square root of negative 1, the same way that 2 square roots of 2 become 2, let me change to yellow here, 2 square roots of negative 1 becomes just negative 1. So the definition of I squared is I squared equals negative 1 due to this similar pattern that we have here. Now here's some example problems. Now we know the square root of 4 is just regular 2, but what about the square root of negative 4? Well, the square root of negative 4 can be changed to this. Negative 1 times 2 times 2. 4 is 2 times 2, and then to get that negative, I'm going to kind of separate it because this guy is our new definition, the square root of negative 1. That part becomes I. And then I've got 2 2's I could break out of jail. So there's 2 ways to break out of jail. A partner, so these 2's come out here in front. They become a 2. The other way to break out of jail is to become a square root of negative 1. These are special secret agents. They need no partners because they're imaginary. No one can see them. So they can automatically break out, but when they do, they change into the letter I. Now, if you want to kind of remember that story, it's pretty easy, pretty helpful. So for 75, I'm going to break it down. So 75 becomes 3 times 25. There's lots of ways to do that. That's the way I saw it. And then 25 is 5 times 5. Once again, these are all its prime factors, but there's a negative. So when you break it down, you're actually going to have that negative 1 separate from all your other factors. And now, break out of jail because you have a partner. Break out of jail because you're imaginary. Oh, sorry, pal, you have to stay in jail. These are the skills you're going to need for working with complex numbers, which are imaginary numbers. Now, in terms of writing these, the best way to write them is always the square roots at the end with whatever number goes in here, and always putting the I after a number. Okay, so don't write I5, that's weird. It's the same way as writing 5x versus x5. You'll always write 5 and then the x. Same thing with complex numbers, you're always going to write the 5 then the I. Now for this one, you're going to break it down. So for this one, the first one is 10, which is 2 times 5. Okay, so I got the square root of negative 1, because there's a negative, times a 2, times a 5. And for the second one, I've got 24. What the heck is 24? Oh, that's a tough one. Let's go 8 times 3. 8. I know a lot of people go 4 times 2, but I like to go right to 2 times 2 times 2. So this second one is square root of, since there's a negative, always put that negative 1 so you can identify the I. You don't really need to when you can shortcut it, but then I'm going to put my 2 times 2 times 2 times 3, and then jail breakout time, no partners here, but I've got a negative 1, so this guy is an I square root of 10. I still have a times in here all the way throughout. The second one, that's my I. Make sure it looks like a negative, not a dot. So that my I comes out. Oh, but I've got a pair. So that comes out as 2, but instead of writing it after the I, I'm going to write it in front. And then I've got friends, that or people that don't have any friends. So then 2 times 3, I could rewrite it as 6 if I want to. But now I'm going to continue this because I can still go farther. This is I and this is I, so that becomes I squared. So there's a 2 outside, then there's an I times I, just like x times x is x squared, I times I is I squared. And then I've got this 10 and 6, so that's my collection here. But instead of writing 10 and 6, I'm going to write 10 as 2 and 5, and 6 as 2 and 3. You can combine them when they're multiplied like this, because you have another pair that comes out. So now I'm going to do a couple things here. Do you remember what this was from the previous slide, I squared? That's a negative 1. I have this 2 right there. I have these partners right there, which also come outside. And then I have a 3 and a 5 that have no friends, so I can change that to 3 times 5 or 15. And now I'm running out of room here, so I'm going to put my answer way over here. And that is 2 times 2 is 4. Whoops. And 4 times negative 1 is negative 4. I multiply everything outside. Oh my God, there's no more i's anymore. And that's what mathematicians are trying to get at. They're trying to have placeholders so they could fix that. And then the square root of 15. That's how you do this problem. Now for the next couple problems, as you look, I'm going to be doing 2 of the 3, and you're going to do the extra one, kind of like a little assignment. You can pause or just do it later on your own, but to get full credit for these notes, you're going to need to do all of them. So I'm going to start with the red one. So for the red one, you have an addition problem. Just like when you have an addition problem like this, x plus 2 plus 2x plus 8, you are only going to add your like terms. So my like terms in x's are x's, my like terms in Complex numbers are my i's. So these guys are my i's with the double underline. So I'm just going to add them. 3 plus -4 is -1. And that's an I. And then the single underlines are my numbers. And I'm adding, remember, don't forget, 4 plus 7 is 11. So my answer is 11 minus I, 1I. Now, complex numbers, this is kind of weird because in real world, if you ever had 2x plus 1, you should write it in standard form as 2x plus 1. But in the imaginary world, they don't like the x or the variable or the I, which doesn't mean either of those, but they don't want the I in the beginning, they'd like it at the end. So this is the form, A and B stand for numbers, so you should always put the number first and the I piece second. Now the second one here involves a subtraction problem. I really don't like subtractions, I like additions. So what I'm going to do is I'm going to take this negative sign and distribute it in, and distribute it in. Then I don't forget that the negative affects both of these second terms. Now I'm going to repeat what I just did. 5 plus -7 is -2. Make this real part without the I come first, and then add it, or you could subtract it if it's a negative, so let's look. This is 1I. And this changed to plus, so 1 plus 6 is 7 plus 7I. So that's this one. Now, as you do the green one, I'm not going to help you much, but my suggestion is to change this to plus a -4, and then distribute before you combine your like terms. Feel free to pause or do it later on your own. Now we're going to get into some more operations, which is on multiplication and some exponents here. Now remember, I by definition is the square root of -1, but I squared by definition is actually just regular -1. So let's look at this one. We got 4I, okay? But this has a square in it. Before I handle the multiplication, I need to, there's no equal sign, so I need to do regular order of operations. Please excuse my dear Aunt Sally. So there's parentheses, but there's nothing to do inside of them. There is an exponent, so I'm going to take this 2 and distribute it in. You can only do that if it's times inside. So 6 to the second power is 36. And then I to the second power is I squared. The second you see an I squared, you should automatically change it to -1. Now be careful here because there's a times right between those two. And this is 4I. So now all I have to do is combine everything. Well, before I do that, because it's all multiplication, before I do that, I'm going to just change this parentheses to -36. -1 times 36. I should really work inside the parentheses first. Times 4I. And you end up with doing 4 times 36, which is 144. Feel free to use your calculator. 144. And then because you just have this single solitary I, it's 144I. Basically, this is the same thing as combining x's and doing all the same stuff with x's. The exception to that is whenever you have an I squared, change it. So really quickly, I'm going to do this one by distributive property. And then I'm going to change this to -5. Negative times +2, -5 times +2 is -10I. Added with, that kind of distributive gets rid of the parentheses. 3I times 3 is 9I. And 3I times 4, 3 times 4 is 12, so it's -12. And then I times I, here it is, I squared, dun dun dun, which is -1. So I'm going to change this whole thing right here. -12 times -1 is a +12. So then I've got the -5 minus 10I plus 9I plus 12. These are like terms. -5 minus plus 12 is 7, and negative 10 plus a positive 9 is negative 1, but they're i's. And there you have it. This one here involves FOIL. I'm going to ask you to try that one on your own. And don't forget, I squareds get changed. And then this one here, remember when I distributed this 2 to both? That cannot be done in adds or subtracts. That's a very common mistake. So then how do I do squares like that when you have a parenthesis and a minus or plus? You write it twice, just like you do if these were x's. I'm going to almost finish this, but not quite. FOIL 25. By the way, that's how I'd be doing this one. Outers, negative 10i. Inners, negative 10i. And last, negative 2 times negative 2 is a positive 4, and I times I is I squared. Dun, dun, dun. Don't forget to change that guy. And see if you can simplify all this for class. I'll put the answers up there next class, because this video is already going a little longer than I thought. So these two shouldn't be too bad, but the i's are not in there, so you need to simplify them a little bit. I'll do the first one, and then I'm going to ask you to do the second one. So I'm going to start by working with these square roots and trying to break them down. So this first one becomes 4. Can't do anything there, but I can do something to the 9. That's going to change to 3i. Now, I didn't show any work. Do you know what I did there? Hopefully you do. If you don't, this is my work. Break out of jail, 3. Break out of jail, I. Minus, parentheses, 6 minus, square root of 49. I hope you know what I'm going to do here. 7 is the square root of 49. But it's a negative, so I'm going to put an I with it. Now it's a subtraction problem. So I'm going to change it to add. I hate subtractions because they get me confused. And I change. And then I just do my like terms. 4 and negative 6 is negative 2. 3 plus 7 is 10. You get negative 2 plus 10i. It is in complex form, because the I is listed second, and the number is listed first. And this last one, you're going to change these first, and then because it's times, you're going to do some foiling again. So that's it. You should find this section relatively easy. The difficulty comes with remembering always this conversion. That is the important piece of today. Thanks for listening. Do not forget, the couple problems I didn't finish, you need to finish for class next time. Thanks for listening.